Hello friends, welcome you in my YouTube channel. I am Dr. Mohammad Sirajul Faizi, Assistant Professor, Department of Chemistry, LS College, Muzaffarpur. Today in this video, I am going to explain about fluorescence. So when a molecule absorbs light, an electron is promoted to higher excited state, generally a singlet state, but may also be triplet states. The excited state can get depopulated in several ways. The molecules can lose its energy non-radiative by giving its energy to another absorbing species in its immediately vicinity or by collisions with other species in the medium. If an excited state triplet overlap with the excited state singlet, the molecules can cross over into this triplet state. This is known as intersystem crossing. If the molecules then return to the ground state, singlet T1 to S0, by emitting light, the process is known as phosphorescence. The molecule can partially dissipate its energy by undergoing conformation change and relax to the lowest vibration level of the excited state in a process called vibrational relaxation. If the molecule is rigid and cannot vibrationally relax to the ground state, it is then returned to the ground state by emitting light. This process is known as fluorescence. So first look at these pictorial diagrams. We called it Jablonski diagrams. So S0 ground state, S1 and S2. So S2 to S1 internal conversions and S1 to S0 fluorescence, and this is the absorptions. Intersystem crossing, singlet to triplet, and then from triplet to ground state phosphorescence. So fluorescence and phosphorescence. What is the difference? Difference of energy. Phosphorescence have low energy and fluorescence have high energy. So lower wavelength, and this is the higher energy, lower wavelength, lower energy, higher wavelength. The Stokes shift. The energy of emission is typically less than that of absorptions. I repeat, the energy of emission is typically less than that of absorption. Fluorescence typically occurs at lower energy or longer wavelength. Characteristic of a fluorescence spectrum. Kasha's rule. Important rule. The same fluorescence emission spectrum is generally observed irrespective of excitation's wavelength. This happens since the internal conversion is rapid. Some important fact. Upon return to the ground state, the fluorophore can return to any of the ground state vibrational level. The spacing of vibrational energy level of excited state is similar to that of the ground state. The consequence of above two is that the emission spectrum is typically a mirror image of the absorption spectrum of S0 to S1 transition. Look at it here. This is absorption, this is emission spectra of anthracene. You see 1, 2, 3, 4 peak and 1, 2, 3, 4 peak like that. So these are the mirror images. Fluorescence lifetimes and quantum yield. Quantum yield is the ratio of the number of photons emitted to the number of absorbed. Q is equal to lambda plus KNR, where lambda is the emissive rate of fluorophores and KNR rate of non-radiative decay. The lifetime of excited state is defined by the average time the molecule spent in the excited state prior to the return to the ground state. Tau is equal to 1 by lambda plus KNR. So fluorescence lifetime and quantum yield. The lifetime of fluorophore in absence of radiative process is called the intrinsic or natural lifetime. You see 1 by lambda. Fluorescence lifetime are near 10 nanoseconds. Scintillators have large lambda values, hence they have large Q and lifetime. The fluorescence emission of aromatic substance containing nitro groups are generally weak due to large KNR value. So quantum yield is determined by a comparison with a standard. You see the benzene, tryptophan, naphthalene, 2-aminopyridines, anthracene, and quinine sulfate dihydrate, rhodamines, crystal violet, cyclohexane, water. This is the solvents, and this is your compounds. This is the range of the wavelength, and this is the range of quantum yield, and these are the reference. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.